Okay, when the angle of elevation to the sun is 62 degrees, a telephone pole tilted at an angle of 7 degrees from the vertical casts a shadow of 30 feet long on the ground. Find the length of the telephone pole to the nearest tenth of a foot. Okay, actually started a little bit beyond where I wanted to. This was your slide 4 that you're supposed to be turning in. The next slide is another example, a little bit different. What we've got here is, if this is 7 degrees from vertical, that means it would be a 90-degree angle. So this angle right here is going to be 90 minus 7, which would be 83. They want to know how long this pole is. So that would be a small p. Well, actually, I guess a small g, since that's what it's across from. And that's what we'd need to find. So your sine of g over that small g, the length of the pole, would equal this angle right here, sine of p, over that 30-foot shadow. So if we've got right here 83 degrees, 62 plus 83 gives me 145. So 180 minus 145 would give me 35 degrees right here. So sine of 62 over the g, the poles that we need, equals sine of 35 over that 30. Cross multiply, and you have 30 times the sine of 62 equals g times the sine of 35. Divide through by what's with the g, which is sine of 35. And since these numbers match up, they will cancel out. And we have sine of 62 times 30 divided by the sine of 35. So we get that the length of g is 46.2 roughly. So g equals 46.2. Alright, and that is the length of the pole. Exactly the same way we did everything, just now it's got something real world. Alright, this example, what is the value of b? Round to the nearest tenth. Well, in this case, we have two sides and one angle. So with the SAS, we would use the law of cosines. Alright, I have this angle and this unknown, so b squared is going to match up with that cosine b at the end, what I've got. Filling in the rest of it, I've got the b, so I'm going to need the a squared plus c squared, which would be there, minus 2, and then match these up, back up again, 2ac, and the cosine b matches up. So now we can fill in all of our numbers. B squared equals 22 squared plus 10 squared minus 2 times 22 times 10 times the cosine of 44. So this really is just putting all these numbers together. Okay. So, cosine of 44 I'm going to do first. Cosine of 44 times 10, just work my way backwards, times 22 times 2. So that's 316.5. So I'm going to have 22 squared plus 10 squared minus 316.5. Okay. 22 squared is 484, and I know 10 squared is 100. So I've got 484 plus 100 minus 316.5. And that tells me 484 plus 100 minus 316.5. You get 267.5. So I'm going to take a square root of both sides. And there's a square root. It gives me 16.4. So B is roughly 16.4. Okay. Now you could use whatever you wanted to find the other angle, or use another one to find A and C. Use the law of sines if you wanted to. Alright. Use the law of cosine since the measures, again, you've got are two sides and an included angle. Let's see what we got here. So, right here, I've got the angle 60, which is with A, so I'm going to have the cosine of A. That means I'm going to start out with the A squared on the other side of this. So I'm going to have the A's matching, then I've got to have the rest of the Pythagorean theorem, A squared equals B squared plus C squared, minus 2, and then pick these BC's back up, times that cosine of A. So now I've got the whole law of cosines here. And that's going to be A squared, my side, and the cosine of 60 is what's going to end up. B squared is 10. C squared is 8. 2 times 10 times 8 times cosine of 60. So filling that in, we have 60 cosine is 0.5, okay, times 8 times 10 times 2. So you get 80. Alright, so 10 squared is 100, plus 8 squared is 64, minus 80. So 100 plus 64 minus 80 is going to give you 84. So A squared equals 84. Take a square root of both sides. You know it's got to be around 9. So square root, and you get 9.2. So A is approximately 9.2. And that's how you find it. Alright, same thing here. You do not have an angle. You just have three side, side, side. 3 sides. This is also one. R squared is going to be 23 squared. The opposite side is very important here. That's going to match up with the cosine of R that you don't know. So we have 23 squared equals 37 squared, that's the side opposite, plus 18 squared minus 2 times 37 times 18 cosine R. Okay. So 23 squared is 529. 37 squared is 1369. 18 squared, 324. And then you have minus 2 times 37 times 18. 1332 cosine r. Now this has to stay together. You cannot take that 1332 off. Only thing you've got that are like terms here are the 529, 1369, and 324. That has to stay together. So I've got 1369 plus 324 gives me 1693. So I've got 529 equals 1693 minus this thing that's all together. So I'm going to subtract 1693 off both sides. That'll go to cancel out. 529 minus 1693 gives me negative 1164. And that equals negative 1332 cosine r. Now, this is just like having something x, okay, like 2x equals 10. You would divide off what's with the unknown, that divide the 2 off. That's what you're going to do here. You're going to divide that negative 1332 off both sides, and that's going to leave you negative 1164 divided by 1332, and remember it's negative, gives me 0.8739. So I've got 0.8739 roughly. And that's what my cosine r is. Now remember all the way back, we had that little chart, 8739. So somewhere, cosine 8739 is going to be between 25 and 30 degrees. That's what we're looking for off our calculator. So we've got this. You're going to hit your cosine, and it's going to tell me it's 29 degrees. Okay. So if my cosine r is that means that my angle r is roughly about 29.1 degrees.